Hello? Okay, I guess you can hear me. So I'm Tobiasz and I work at Betsys in the Polish office. And today I would like to talk a little bit about Passkeys, about technology behind it, and how to add support for Passkeys in Go. So yeah, first we'll do some fun facts about passwords. Then we'll do introduction to the Passkeys technology. Then I will show you some demo about it. Then we'll switch back to the presentation to talk more about technology behind it, which is FIDO2 or Webauthn. Then I will do live coding and I will do some final words or summary. So yeah, starting with fun facts. Typically, users have more than 90 online accounts, and up to 51 of the passwords are reused. So yeah. And 75% of all hacking-related breaches leverage either stolen, weak password, or some kind of phishing. So there is a website where you can check by your email if or from where actually your data was leaked, because it's very highly probable that your data was already leaked. And you can check there if it was just some email or if it was also password and some other metadata about you. And 89% of organizations experienced phishing attack in the past year. So, only 28% of organizations don't require, like 38% of organizations don't require a second factor. And it can be because, it's not that convenient. So, okay. And this is actually a good slide here, because 79% of the user had some experience using second factor. This is from the report from 2021. And here is a graph showing, have you experienced some kind of second factor during past years? And in 2017, it was only 28%. So right now it increases. So people at least know about second factor somehow. So yeah, right now going to the Passkeys. My question was already stolen, but has anyone used the Passkeys in the past? Oh, yeah, so right now there are a little bit more people. So in simple words, Passkeys are replacement for passwords. They should provide faster, easier, and more secure sign-in. They are phishing resistant, and they are always strong. What it means that, like, you can have weak password but Passkeys by default is always strong because they are based on the public key cryptography. And who's behind it? So I already mentioned it. There's FIDO Alliance, which is responsible for defining standards to help reduce over-reliance on password. And yeah, they have many members, and they are responsible for designing those standards. So before we will dive into the details, let's do a short recap of public key cryptography. So here is RSA algorithm, but yeah, we won't go into it. We'll do something simple. So basically, in public key cryptography, what you need to know that there is key pair, and each key pair consists of public and private key. And those are like long random numbers, and they have somehow mathematical relationship with each other. And yeah, and what you can do, you have two operations on using this public key cryptography. One is encryption. So in encryption, you use public key to encrypt some message, and only one with private key can decrypt it. And the second one is digital signature. And in digital signature, you use the private key to sign the message. You pass the message and the signature, and then the one who has the public key can verify the message. And actually, this digital signature, it's used in this Webauthn technology. So right now we'll see how the registration and authentication look like in details. So first, let's start how we register the passkey. So on the blue, there will be user, and on the green, there will be our web application. So there is a new user, he wants to create the account. The backend responds, sure, send me your public key. So then on the operating system, we are creating this new key pair, and we are sending to the backend only the public key. And that's all from the registration. Then on the login, the user comes again, and the server responds with some challenge, gives the challenge, and asks to sign this challenge, and I will verify using your previously sent public key if this is really you. So what the user is doing via operating system is creating a signature using the private key stored on the operating system, and is only passing the signature. And the server is validating the signature with the public key, and that's all. So let me show you the demo, how it looks in real life. So here I have some example website where you can test it. And I just need to put some username. Okay, and I can continue. And then I have the pop-up from operating system where I want to keep it. I can either keep it in iCloud keychain, use the external security key, or use my Chrome profile. I will go with Chrome profile. And now I'm passing my biometric check, and my passkey is registered to this website. Here is important pop-up that will come back later. Basically, it's saying that my passkey is not a backup, and if I lose it, I will lose access to my account. But we'll come back to it later. Right now, if I sign out, and I will try to log in again, my passkeys is auto-filled here, and right now I'm solving this challenge, and I'm in. So this is the whole process of signing up and signing in. Okay, going back. So yeah, let's talk about the security features of the FIDO2. So credentials are unique per every website. So for every new website that you want to register, new passkeys is created. And private key is not sent to the website or the application. So it also means that server no longer stores secrets about the user, because server only store credential ID and public key. And on physical security key like YubiKey, the private key actually never leaves the device. And passkeys by default are unphishable because you're not typing any code. And they have also protection to the replay attacks, because every new ceremony is for every new ceremony, the new challenge is generated. So you cannot use replay attacks to try to break in. And yeah, and we can use passkeys in different way. We can go with passwordless. So this was what I showed you in the demo. So you have completely passwordless experience. But you can also start using it as a second factor. And this is quite important, because that's how typically companies start rolling out passkeys. This is how Amazon is doing it right now, or Google. They let you set up your passkeys, and it will start with using it as a second factor. And then they can offer the passwordless login, and basically then they can start requiring the password. And this is how typically companies who already have some kind of authentication system are rolling out passkeys. So if I have passkeys, do I need second factor? So theoretically, passkeys feels both factor. First is something possession based, because this is something you have, and second factor because it's inheritance based, because every time you sign the challenge, it's gated by biometric scan of your face or finger or your PIN, if it's YubiKey. So if you want, you can skip second factor if you start using passkeys. So yeah, let's look at the adoption. So Webauthn specification was released, the first version was released in the 2018. And unfortunately, like initially the adoption were quite slow. And first of all, it was because of bad UX. So different browser like were supporting it poorly. Like there was a lot of problem with Firefox. And it's starting getting better and better. There's this new feature, autofill, which I think works good. And right now, I would say it's better. And the second factor was lockout risk. Because like initially, when you are creating the passkeys, it was bounded to the device. So either to your YubiKey or it was stored on the secure enclave in Apple. So it was not exportable. But it also means that if you lost device, you are basically locked out. So what company were doing, they were always requiring to set up more than one passkeys. So for example, if you go work to some security company, they were always sending you two YubiKeys. And one should be used daily, and second one should be stored in your drawer or somewhere. But basically, this lockout risk and slow and bad UX were resulting that the adoption were quite slow. And it changed a little bit in 2022. There was Apple conference where they announced passkeys, because previously the passkey term was not existing. So they put the fancy name on it. And what they also did, they solved the lockout risk. So right now, they are offering that when you create the passkeys, it will be stored in your iCloud keychain. So whenever you create the passkey, it will be available to all your other Apple devices. And even if you lost that, as long as you can recover your Apple ID, the passkeys will be there. It has, but it's worth mentioning that this is like slightly degraded security, because right now these passkey are exportable somehow, but no, that's how they improve the UX of it. And if we look right now on the website that supports it, it shows that the adoption is increasing in the last 2 years since this Apple conference. And yeah, and with Passkeys, as I mentioned, we have option to either use this cloud sync or device bound. So with sync via cloud, also Google supports it. If you're signed in, you can store it in Google Password Manager and it will be synced. You can store it on your physical YubiKey. This is the most secure because the private key from there is not exportable. And for example, Windows Hello still offers you to store it without sync option. So you can store it in TPM and it will be like almost as secure as YubiKey, but yeah, you need to store at least 2 of them to be sure that you don't have this lockout risk or have some kind of recovery mechanism. And there is also one other option. So for example, if you want to log in on the external computer and your passkeys is stored on your phone, then you can use this option. So you're basically scanning QR code. In the background, there is Bluetooth proximity check, and you can log in via you can solve the challenge on your phone, and the computer will be allowed to log in. Okay, and the last part of this whole specification is how we are interacting with it on the front end. So on the front end, we have and I will do disclaimer because I'm not the front end developer, but yeah, so there could be some things wrong. But basically, you have browser API for access. So typically, how you interact with credentials, you have this navigator credentials, and right now, there is option to pass their public key option. And instead of creating standard credential, you will use this API for accessing public keys. And here is the whole specification, how to interact with it. And yeah, so here is the flow. This is the registration flow. Later, I'll show the authentication, but they are very similar. So first comes the user. He wants to register, so it passes the username, and each ceremony consists of 2 steps looking from the backend perspective. So first is start of registration, and second step, which is another endpoint, is verification. So on the registration start, backend generates some options, so it will return like what's the server ID, etc. Here it comes back to the front end. Front end via this API interacts with operating system. We are creating here this new key pair, and we are sending the public key back to the server. This is registration. Then on the login, we are asking, it can be with user or without. We are asking backend to generate us the challenge. So server is returning us the challenge. Here again, frontend is operating via operating system, and challenge is signed only after the face or fingerprint scan, and the solved challenge with some other metadata is sent back to the server. Okay, so how does it look in Go? So in Go, we have one package which is like most popular. It's called this Go Webauthn. And it provides us the helper methods to basically do the validation of the signature, and it does most of the job. So we will see in a second how to interact with it. But it's worth mentioning that they are still before V1, so there are breaking changes which are happening sometime. I'm using it for 3 years, so 2 years ago there were more breaking changes happening. Right now it's fairly stable, but it's still before V1. So yeah, right now there will be a live coding. Yes. So okay. Okay, so I have a lot of boilerplate prepared, so I will talk a little bit about it, and then we'll implement just one method. So first of all, this Webauthn package might have like a new method which allows us to construct this Webauthn object. And what's important here is this relying party ID. This is basically the origin of our server. I'm using here localhost because I'm doing it on the local, but it's worth mentioning that you cannot change this relying party ID later. Like if you change it, all the already registered authenticator will be lost. So it's worth mentioning how you interact with the relying party ID. You can find, I also have some reading materials prepared at the end of my slides, and there is explanation like how to interact with it, but this is like worth mentioning. And then we have this authenticator selection. So this allows us to specify if we want to use our authenticators for like full passwordless experience, or for example only for second factor. But because if we want to use it as a second factor, then on the YubiKey we'll just require the tab. We won't require to put the pin. But I'm doing here the full passwordless experience. And besides this Webauthn object, we will have two stores. One is maybe I will show you the interfaces. It'll be easier to talk about it. First one is user store. So this is the interface for storing the user, and it's very simple. I'm using here in memory store, but basically what's important here is the user. And as you can see, the user has ID, name, and credential. And this credential, as I said, this is no secret. There is only public key, credential ID, and some other metadata. And if you want later, I also have some materials that show how to, for example, design the SQL schema about the user, if you want to store it in the SQL database. And the other store is the session data store. It has 3 methods: get, add, and delete. And maybe if we go back here, because as I mentioned previously, like each operation, like each ceremony, either login or register, consists of 2 operations. So we are starting logging here, and then we are validating. And the session data is used, like it should store the data which you're creating here, and then you are using it on the validation. So this is like more like temporary store, because it should only exist for like during those 2 requests, and it should also have some kind of TTL, because the whole ceremony should not take longer than defined timeout. By default is 1 minute. So basically you need to store this session data for maximum 1 minute or the timeout that you are using. But yeah, so they are basically used in the ceremony. And yes, and what I have here, I have 4 endpoints. So as I showed before, 2 are for registration. So I'm generating registration option, verifying it, and I'm then generating authentication option and verifying it. And due to the time constraints, we'll just implement the authentication. I think it's more interesting. And the registration is already done. And yeah, I will share also the code is on the public GitHub, so you can check it later if you want. So this is a start of the login. So right now I need to generate the authentication option. So what I'm doing, I have here this Webauthn object, and I'm using the method begin discoverable login, because this discoverable login means that I'm not passing the username, I'm allowing the autofill to choose it, or to choose it from the existing authenticators. This method is returning 3 options. So it's this credential assertion, session data, and error. What I need to do, I need to check for the errors. I have here some handle method which allow me to handle errors. So if something goes wrong, I will just return internal error. And that's it. So here, this is the options that I'm returning to the front end via this endpoint, and I also need to store the session data inside my session data store. So what I'm doing, I'm just adding this session data, and that's the whole generating of options. And right now we'll go to the verification. This is more interesting. So on the verification, the front end will send us in the body the solve challenge. So Webauthn package adds us the helper method to parse it. Okay, so it should be this one. So this is I need to again handle error. And then I need to take the data from the data store. So I have the session data store. I will use get. It needs challenge. I will response challenge, and I need to get it. This interface is really simple, so I'm just returning nil if I cannot take it. So I need to handle error if session data is nil. And then I need to, according to specification, immediately if I get the data from the session data store, I should delete it. So no one can reuse it, even that it expires. But whenever I'm starting using it, I should immediately delete it. So I will do it. And so right now I have the parse data from the body. I have the session data return from the session data store. I need to validate the login, and then I need to add it to the credential. So first thing, I will use again this Webauthn object, and here's method validate discoverable login. It requires few things. So first one, it requires the function that return us the user, because this is this discoverable login, so we don't know which user it is, but it passes the user handle, so we can use right now the user store and get by ID. And we'll take the user. And if user is empty, we just return nil. And else I will return user and nil. And to this method, we also need to pass two other arguments. One is this parse data, and second one, no, first is session data, and second is this parse data. And it returns us the credential and error. So again, we need to just check for the error. And we need to add this credential. This is actually the update of the credential, but we'll add it to the user. And that's all. We'll run it in a second, but I want to just show you, because this is actually the clue of this whole algorithm, this validate discoverable login. And if we go here to this validate login, it actually like follow the steps of the specification, and it is very clear described here all the steps that it does, and here is all this signature check, and if this is for the valid relying party ID. So this is really the clue of this algorithm for validating these passkeys and this challenge that is solved. So it follows all the steps, and you can check if it's according to the spec. I was checking it once, and it was according to the steps. Like there was some skipped part, but they are not important to this kind of, to this default feature of passwordless. Okay, so right now we'll try to run it. Okay, it's compiling. So this is first success. Okay, so right now I will try to mimic what was there before, but okay, so I will just create user one, and I'm using the sign in. I will again use my Chrome profile. So I was able to register, but it was already prepared. So actually the sign in is the test of my live coding. So here it suggests me my user, and I press OK. So I'm actually authenticated, and here you can see, like you can see, but if you trust me, here are the valid responses from the back, from the front end, and the responses from the back end. And if I refresh it, so I'm mimicking the new login. If I go here, it automatically allows me to choose my user to sign in. So this is really like one click, and I don't need to type anything. And also this autofill works, so it suggests me my username here. Okay, so that was the live coding. And yeah, some finishing slides. So for summary, what it means to the end user. So first of all, if the passkeys are not available, like based on these fun facts about the password, if the passkeys are not available, you should always use password manager and use the random strong password. And if any second factor is available, use it. It's still better than nothing. But if the passkeys is available, I encourage you to at least try it, because it's really convenient. And like maybe it's not that popular in Czech or Poland yet. On the international side, it's more popular. And for example, most of the companies already support it on the single sign-on, so you can try it also there. Because it's secure by default, then it's also phishing resistant. So then whenever there is some phishing simulation, you don't need to sweat like it. And what this means for developers who have somewhere the custom authentication system. So for example, if you need to add second factor to your authentication system, you can consider adding it via Passkeys. For example, if you have a requirement to support YubiKeys, you can implement Passkeys and you will have both YubiKeys and platform authentication supports. And then if you have it as a second factor, you can start rolling it as a passwordless sign-in. So at the end, there is a question like, will passwords become a thing of the past? And if you ask me like 3 years ago, I would say probably not, because the adoption were quite slow. But right now, I see a little bit like that it may be possible, because like big companies are starting rolling it out, and they really prepare some education about it. So this is really important to educate user about it. So maybe it will be the thing of the past. And I also prepare some reading materials that you can use. So here, first of all, there are case studies of the different companies and how they improve something using Passkeys. And you can find more in this link. Then I prepare some general info about the Passkeys and Webauthn technology. And at the end, I prepared materials typically for the backend. So how to implement it from a server-side perspective. So this Google material is really good. There you can find this example SQL schema, and also the information about this relying party ID that you cannot change it. Also, the Ubiquitous materials are quite good. Here is this library. Then this Hanko. This is the open source authentication system in Go that I found that is actually using this Webauthn library. So you can check how it works in the production. Like, I'm not sure if this is like, they are saying that this is production ready code. I haven't used it myself, but you can, for example, check how it's implemented there. And in the end, you will find my example that I was live coding here. And that's all.